Today I'm going to show you how to recap the G1 Honda Insights DC-DC converter. As these are aging, the capacitors seem to be failing across the board. So I recommend you recap before your DC-DC converter fails, but you can also do it afterwards. You just might have to replace extra parts. We'll walk through that here. So the first thing you need to do is get the DC-DC out of the car. I have a separate video showing how to do that. And you also need to remove the cover, which I've already done here. And you also need to remove the 12 screws. There's 2, 4, 6, 7, 8, 9, 10, 11, 12 screws. Those are all Phillips heads. I've already done that. And the first thing we're gonna do, if your DC-DC is not broken, then you probably don't need to do this. But if your DC-DC has failed, like the fuse has popped on the junction board, it's probably this 2.2 ohm resistor that is blown out. And you can rework that. I'm not gonna show that in this video because I'm gonna assume you've done this beforehand, but if this does blow out, I do have a part number linked that you can get to replace this. So once we've removed the 12 screws, we need to lift up on this guy here, and there's a big thermal mass down here that has adhesive on it. It's not adhesive, it's a thermal paste, and you need to remove this, and we're going to fold this up, and then you can see there's 2 connectors here. If you just pull on these connectors, there's no tab, you just kind of pull straight out and they will disconnect. So do that. And then we're going to work on this board. So you can set this entire assembly aside. So set this board right side up, just like this, on your work surface. And you're gonna remove that just out of the way. We won't need that again until we put everything back together. So the first thing I recommend doing now that you have this board off is to take a paper towel or whatever, and some rubbing alcohol. I recommend 99%, but 95 works as well. 30 is not so good, so try to get at least 90, 95. We're gonna wash all of this off because if you don't do this now, it's gonna get all over you and you'll regret not having done it earlier. We need to do this eventually anyway so that we can put new thermal paste on before we put this back together, because 20, 25-year-old thermal paste probably not gonna do very good at this point. So make sure you kind of come over the sides as well and clean the stuff that's hanging over the edge, just so you're not getting it all over you. It's just annoying if it gets all over you. So the next thing we need to do, I'm going to take a plastic spudger here, and you can see the 9 capacitors we're going to replace. I've labeled them on this one, which has already had them replaced. You can see some of them are a little different. And these are not glued yet, but basically these are glued, and we need to remove that glue so that we can you know, remove those capacitors. So I'm going to set this guy aside for now. We'll come back to him once we have removed all the capacitors. You don't need to remember where these capacitors go, because I'll show you where they go when we reassemble it. I do have my screen over here, and that way you can kind of see what I'm doing. This auto exposure can be wonky, but I'll make sure that it looks decent. So what I'm doing is I'm taking this plastic spudger here, and there's 9 capacitors. It's all of the electrolytics. What is wrong? There we go. We're gonna remove 1, 2, 3, 4, 5, 6, 7, 8, and 9 electrolytics. They're these brown ones. We're not gonna remove these red ones, so don't remove those. There's 4 or 5 of the red ones that we're not removing. It's only these brown ones. And so yeah, the first thing we need to do is just come into each capacitor here, and we are going to just, again, I would recommend a plastic spudger. We're going to just remove this material. You don't need to worry about damaging these capacitors because we're about to remove them and replace them. But pulling this silicon off now is going to make removing this stuff easier. So I'm just coming in, just ripping that off. Right, here's the next one. Again, on these electrolytics that we're removing, you can be as hard on them as you want because they are going to go in the trash. So there's 2. Here's this third one here. Okay. Just keep going. See if I can get in there. Yep. Again, as you're getting close to C552 here on the top and the right side, err towards putting pressure on this guy because we're replacing that C551. Okay. And then we've got 2 more up here. These are the harder 2 capacitors to remove, in my opinion. They're a little bit tighter and there's a little bit larger thermal plane underneath. It's all still doable. I am going to do this whole video in one cut so you can go through the same issues I go through. Okay, so now that we have all of this removed, I want to show you what these leaking capacitors look like. And on this board, I haven't really looked at it yet, other than I noted that this one's not as bad as the other ones I've looked at, but it still needs the caps replaced. So if you look right here on this C204, zoom way in. So, sorry, there's a smaller field of view here. Get that all the way in focus there. So if you look at this pad here, you can see there's some green something there. That, you know, we have the green of the traces here, but this was originally a soldered pad that this capacitor soldered into, and it now has leaking electrolyte on it. It's not that bad. You can see how this electrolyte has started to attack the copper here underneath this solder mask. But in general, this board is in really good shape. This is the one thing, when you look at my form, I ask you, is there any bridging or material on IC201? This is this end-of-life part here. It's got a silicon cap over it. What I'm asking on that question when you fill out the questionnaire after you've done this repair is, do you see any debris or damage here? Now, there is what looks like flux here. This sparkly here is probably some residual flux from when this was manufactured 20 plus years ago. In this case, on this one, I would say no, there is no debris or whatever flux or not flux, electrolyte between here. The first one I looked at had some much worse. We'll look at it next because it was in much worse shape. But yes, this capacitor has certainly leaked. That's C204. Let's look at C203. I don't see anything there. This is all mechanical abrasion, probably from where I was just cleaning that rubber off. What's next here? So C303 here, I believe. In general, I don't recommend moving those capacitors, but again, we're about to replace these. So yeah, C303 has definitely had some leakage here. You can see that leakage right here. This is not flux in this case. Flux is typically going to be sparkly like we looked at a second ago. But you can also see where the electrolyte has leaked out here onto this leg here and deformed the board slightly, really from etching. So yeah, this capacitor has also failed. You can just see the leakage. When we get these capacitors off, you'll really see it better too. But you can also see where the electrolyte has leaked out here and is attacking this copper surface down there. So let's look at C551. I need to zoom out a little. I don't see any leakage on C551. Doesn't mean it's not there. Again, when we pull these off, you might see it underneath. I don't see anything immediately there. And I think we already looked at these, but I don't remember, so let's just look at them again. I don't see any leakage there either. All right, so the next step then is that we need to remove these capacitors. And as I said already, these capacitors are going to heaven after we take them off. So you can be as brutal on them as you need to get them out. Now, I'm going to use a board preheater, which is underneath here. And this is just blowing hot air up from the bottom. I expect you probably don't have this, and you could do what I'm doing with a hot air gun. We're just going to be heating the board to make these easier to remove. And I could probably do this, you know, I could certainly do this, but I'm going to try to make this film as short as possible. I'm doing it in one take, so I'm going to use the tools I have. But you know, if you end up needing more heat, then you can use a hot air gun. I'm going to just use this board preheater. And so I've set the board preheater, it's probably around 200 degrees maybe, I'm not really sure. What I'm going to do is I'm going to flip this around, and I'm going to just note where all of the leads are so that it's easier for me to find them. So I'm just taking a Sharpie here and I'm going to say, okay, that's coming off. This one's coming off. These are coming off here. And so there's 5, I think. We're going to take these off here. And that's coming off there. And these 2 are coming off here, like that. And then also this guy right here, I'm just feeling it from the bottom. So we do want to make sure we remove the right components. I'm also going to take and cheat a little more and just use this board holder, maybe. It's kind of tall. I think I'll turn it sideways. Again, you in your own time will be able to do whatever. I'm going to try and make this video as short as possible. So let me cheat. Please allow that. Okay, so that probably needs to be a little higher. I always keep extra metal around. Okay, so we're going to use these aluminum bars here, like that. Probably just use the one. Oh wow, I cut my hand. Whoops. All right. Aluminum normally won't do that, but got a sharp bar of some kind. All right, so we're going to heat this up like that. We're just trying to get heat in the board wherever we can. Seems like I picked the wrong. This is the wrong little dot there. Again, these are just templates for yourself. That's that capacitor right there. So next up, we're going to use the biggest tip you've got. I recommend a 3 or even a 4 millimeter tip. Man, I don't think that's going to stop bleeding. Let's see. All right, well, whatever. So we're heating this up. I recommend the largest tip you can find. I'm using a Hakko 888D, 120 bucks. It's a great iron. My only complaint with it is that it doesn't automatically turn off. If you have tweezers, the FX8804 tweezers are going to be much, much faster, but I just assume you're not going to have those. Those cost more than the iron, just, you know, the body does there. So I'm just going to assume you don't have that. And then I'm also going to use this just to evacuate the air. And from underneath, again, these capacitors are not being reused. So as long as you know you're touching the right component, which you can look under as often as you need to, you're not going to damage this capacitor any more than it being in the trash can is going to damage it. Let's see if I can get this here. Okay. Is that too high? That looks terrible. One take, you get to see all the problems too. This needs to go higher. How much higher can I go? I'm already like way above the end of the bar. Okay. That looks better. Okay, so the first thing we're going to take off is this cap here. And when you're removing stuff like this, you really want eutectic solder. So I'm using the MG Chemicals, that. It's probably really bright. But this is a 63%, 37% solder. The 6040 is 10 degrees Celsius hotter to melt than this perfectly eutectic solder. So get the 6337. It'll make your life easier. So I've pulled off a piece of it here, and I'm going to just flood this area. So the key trick for me on getting rid of parts is to put a lot of solder on them. A lot of people try to suck that solder away. There's no reason to do that because you want that solder to get the heat in. I'm like, why am I breathing this? I don't have this vent open. There we go. Okay, so I'm heating this pad up and I'm gonna just rotate the part. I just pulled it towards me a little bit. We'll let that pad cool off. And then I'm gonna heat this other one and I'm gonna push that part away. Those parts are gonna get hot on the bottom. Here's the first cap removed there, and we're gonna just take it and just throw it in the trash. And we're gonna do that for all of these capacitors. So we're gonna, ooh, it's getting real hot. The board preheater is doing its job. Okay, so I'm gonna switch over to tweezers now because it's very hot. If you're using a hot air gun from the top, obviously it won't be so hot on the bottom. I've lost my solder. There it is. Okay, so we're gonna go to the next cap. We are going to remove our solder. It's right there. So I'm gonna flood that. And then I'm gonna flood that one. Okay, nice. So we're gonna just rock these back and forth till the part comes out. There's our second cap off. Oh, you know, I shouldn't have thrown them out because I can't see if they're leaking or not. Let me go dig that first one out of the trash. Good, it just kind of landed on top. Oops. And now it's in the bottom. All right, well, we're gonna look at 8 of the 9 capacitors we're replacing because I don't want to go fishing for that. Okay, so here are our next capacitors here. Let's see. Oops, fell off our holder. Rather, our holder opened up for some reason. Tighten that up. All this stuff's so much harder to do on film, so thank you for bearing with me while I struggle. Okay, so next are these two right here. You can see our dots we put in. So we're gonna take our iron again, take our solder, and this is the hardest one to remove, probably right here. Here's where you might actually need to use that heat gun or a board preheater if you have it. But it's working just fine here. I'm actually only using I think a 2.5 millimeter tip here. That one's, it's leaning against the transformer, so I can't push it from the bottom, so I'm gonna just kind of like push that tip down there. Now I can reach it from underneath, like that. Okay, and then I'm just going to heat this up, pull that pin down, and just keep doing the same thing. All right, so we had that capacitor just fell into our board preheater. We'll get it later. Those board preheaters will take a lot of parts before they short out, so not worried about that. Okay, pull that down. So I'm just rocking the part backwards. So if we look at what I've done right now, you can see that underneath I have basically this part's pushed over because when I had it heated, I just pulled it that way. Now I'm gonna push it back that way and we're gonna just rock it out until it comes off. I guess the heat is making these open. My jaw keeps opening on this. I just had them both loose. Don't know. Okay. So I'm back on that same cap over here, and just going to take and push it now. So now we've pushed it the other direction. Now I'm going to reheat this pad, pull it, that pins out, push it. We dropped another cap into our board preheater. Okay, next up we've got that guy right there. So we're again going to take our solder, put our solder on there. You can see as our new solder comes on to what I think is probably lead-free. This feels like lead-free. It's certainly not eutectic leaded solder. It just makes everything better once we get our good solder on there. So I'm just rotating, pushing that off. It's going to take a little minute. There we go. Okay. Pull this off, so that pins out, and now that one fell on the floor. We'll see if we can find them all later. Okay, next up, we've got, I might need to come in a little, falling off my table. Okay. So we're going to take that guy off, if I can reach it. Yep. Okay. We got that. We're putting some more solder there. Okay, I've got my finger on this guy. I'm going to pull him towards me, and then I'm going to heat this other pin, push him away, pull him towards me. That one landed on the table. So here's that guy. So far I've collected 2 of the 7 or whatever, however we've removed. Okay, so we need to remove these 2 right here. And so once again, I'm going to take my solder. This board preheater is not doing that much work. So really, if you just heated this up with the heat gun, it would probably give you a minute or 2 to work. You know, having the heat from the bottom is helpful, but you don't need a board preheater. Okay, so I pulled that towards me, and now I'm going to push it away, and then I'm going to pull this guy towards me, and then push that guy away. So that's out. That guy's bulging a little. Okay, and I believe I already hit that one. Yep. So we're going to pull this guy towards me, push that guy away. Ooh, yeah, the board preheater really heats your hand. Okay, guy's bulging too. I think we have one more, so and it's all the way down here. I need to just go that way some. Okay, so here's our little 2. I think it's 2 microfarad. Doesn't matter. So that's coming off. Okay. Notice how I'm waiting for this solder to re-solidify before I switch. We're using these leads to, well, I didn't actually do that, but we're using these leads as mechanical advantage. Okay, we got that pin out and that one. Okay, I think that's all of them. Let's turn it over and check. So yeah, we've removed 1, 2, 3, 4, 5, 6, 7, 8, 9 caps. So that's all of them. All right, so the next thing we need to do is we need to get rid of all of this solder that's in the holes. And I recommend starting on the back here. And I'm gonna come back over to here, reclamp this like that. And then I'll set it right there. Maybe that'll be good. This one's a little shorter. Yeah, I like that. Okay, so let's get the solder out, and I recommend starting over here because these are a little bit easier. I'll just show you how to do that. Okay, so we're going to start on these 2 right here and right there. They're by that IC201. So my first recommendation is to go ahead and just take your solder again, and we are going to essentially try and push this solder through that hole, and we do that by just kind of like, you know, getting that flux in there like that, and we're going to just do that to these holes. We're trying to get rid of that old solder that's in the holes. Ideally, it will be leaking out of the bottom once we're done with this, so we can flip it over and look and see. But yeah, the trick to getting rid of the solder out of these holes is to put all, you can see that just fell. You see how it just bloop? So we're actually building a little column below that now. So that's going to be good when we go to wake that all up. Not going to happen every time, but these all look pretty good. That one just dripped down too. So when you put this on in the hole and the solder blobs get smaller and it's not just pooling up on your tip, that's a sign that the solder is kind of falling through. So that's good there. Clean all that solder off. Okay. I'm going to put a little more in there. Yeah, so that's falling through. We've gotten that one really good. Next I'm going to take some solder braid. This is a pre-fluxed solder. I'm using Superwick 454. I love it. I highly recommend it. You don't want to breathe it in, so make sure you have some kind of evacuation. I have an evacuation thing there. To get rid of this solder now, we are going to take our wick, and every time I put this wick down, you'll notice I'm using a different spot because I want this flux to be in there every time. So I'm going to take this tip here, and we're going to just try and get as much heat as we can. And notice I'm just kind of moving down there, and we've already made it most of the way through that hole. You don't need to get all the way through on this side because we're about to just flip this over and do the other side. So that hole we got through there. This hole we're getting through, it looks like. There, yep, so we got through there. This hole's going to be a little harder because it's already fallen through. So just do your best like that. You can see I've got a dimple down there. This is going to clean up just fine when we go to the other side, which you don't need to do now, but I'm just going to show you how to do that now so we can see what the other side looks like. I could probably just flip this over. Yep. So yeah, check it out. Okay, on the other side, this just lies flat-ish. We were just working on here. Here's that hole that kept falling through. Look how much solder is on that now. I know it's not in focus yet. I'm going to get there. This probably needs to come way down. Yep. Look at all that solder that came through there. That's great. That's exactly what we want to see, because now we can just come on this side with our iron, and we can just come in and just soak all that up. And one of the tricks here is to do it quickly, because you want as much solder in that hole as you start to do this. Okay. You want as much solder in that hole as you can so that it wicks down. Now here I'm going to remove just some of this material that's here, just so I don't have to smell it. Probably should have done that before we started this, but again, I'm using a plastic scraper here, so I don't have to worry about damaging anything. Okay, so this hole on the bottom is still full, and so I'm going to actually refill it with solder, because you're never going to get the solder out of the middle once you've tried both sides. It's just not going to happen. Unless you're using like a solder sucker. I don't use solder suckers, but Sean has said they worked really well on this board. So if you have a solder sucker and you want to use it, I don't even own a solder sucker at this point. I stopped using them a long time ago, because with the proper soldering equipment, you don't really need them. Okay. Oh, I think I was through for a second. Okay. Yeah, so I'm basically getting through. I think when I turn this back over, I'll be able to tack it. These two are already clear over here. So let's flip this back over and look and see what we've done. This back side is generally easier to work with, so I would err towards doing your work on the back side. Let's see, what two have we done? Those two are finished. This one we're still working on here, so we'll work on that one a little more. It's good that this doesn't work every time here on video, because you get to see the struggle too. So we're going to fill that hole back up. Notice I'm just putting this solder in there like that, and then you could just get that solder off your tip to save a little bit of wick. This wick's not that expensive. Notice how even though I have this, like, I don't even know, 10-meter roll of it, what is it, 15-meter roll of it, I cut it off and work in it with like 8-inch sections. It's just much easier. They have little handheld smaller rolls. I've never really liked them. I always just prefer cutting this off like this. Personal preference. Okay, I'm really getting, it's funny because this is not a hard signal, but this one for some reason is just not cleaning. There we go. So we got that one clear. We'll clean that one up again a little more when we get to the other side. So next up we'll do this guy right here. Just like before, I'm going to just stick some solder on here. The trick is more solder, not less, so just remember that. We want this solder to get inside that hole. Put that old crappy solder out on the street. Okay. I'm going to start with this little leftover piece of wick here. See what I can do with that. Oops, stuck to that one. Okay. Yeah, don't try to conserve this wick because it's just going to make this harder. It's not that expensive. Just buy more if you need more. I'll probably use a meter of this cleaning this board off here, just for a reference. You know, like a couple bucks. Whoops. Try not to touch the other parts because you might have to go back and rework them otherwise. Okay. So there's that guy. We'll flip this over like that. What are we working on? Yeah, we're working on that. So you can see that once again here, the solder has actually started to come through even though we actually have silicone there. Let's go ahead and clean all of this old adhesive off because it's just kind of getting in the way. So we'll clean that off. That is, I thought it was through, but it's not. Okay. So we'll go ahead and attack this from this side. You can see this has these pads here. You see the 4 little things. Those are thermal reliefs that should make this a little bit easier to do. So we're going to first put solder on. Again, we want to get rid of that old crappy solder. And we're going to do the same thing over here. Burn that silicone a little. Okay. And now we're going to take our braid, clean this up. So the tip that I'm recommending for this, I'll have in the comment or wherever in a bomb somewhere. It's not this tip. I ordered this tip. It didn't arrive in time. I figured, what the heck, let's do it. The tip I recommend has a nice conical surface that you can hold this at an angle and it will get a lot of heat in there. This is just a straight tip, and so it's not ideal, but it's not the worst thing. Man, look at that balling up. That's great. And what the heck, I'll keep this down. Why not? So this is what we want to see when we flip this over. We want to see a bunch of solder. Remember, we already looked at this before and we got rid of all that solder. That means that we've now gone through this and gotten all of that old crappy solder out. It's what's in that bulb now, so we're going to just suck that up, and then we'll be in no time. The other one's not so much, but we'll just keep attacking it here. So notice that I'm moving this rather quickly because, again, I want to get this out as fast as I can. I just want to keep wicking this solder out, and you can see there is a ton of it. Okay. We are most of the way through there. As Sean mentioned, again, yeah, so boom, we just popped that one. That's great. As Sean mentioned, if you have a solder sucker, it appears to work very, very well. You can see this really dark brown here. This braid has a corrosive flux in it. So you do need to make sure that once we get this off that you do wash it. I will definitely show you how to do that. So we're going to do the same thing. Come here and just attack this. The goal here is flux. We want flux going down in there because that's going to pull this copper off. I think that's through, but there's so much flux I can't tell. So one way you can figure out is to just take any old through hole part and just see if it'll go through. And we're not quite, but it's close. But that one's certainly through. So what are we going to do? We're going to flip this back over. And you can see that this this top guy now has a little bit of solder bulbing up on it, but not much. So we probably still haven't shot that old solder out. So I'm going to just add some more solder here. Okay. And then we are going to take our braid, clean that tip off. Got a bunch of crap on it. Okay. Try again. All right. As soon as I get the solder off this side, I find that just turning this back over and attacking it from the other side is much easier. I'm also going to take just a little bit of alcohol and a Q-tip here to clean some of this flux off. This flux has burned so much that it's probably not doing very much. So we'll clean that flux off. And that way, as we get the new flux on, it can be really nice and active. And hopefully we'll blow that hole out here in a second. I'm also going to cut, once you have like only 2 inches left, use that on the beginning of your next attempt, because you want to be able to run as many inches of this as you need. So here I've just cut another piece. It curls up, so I'll typically take it and just do that to just kind of uncurl it a little bit so that you're not fighting with it. And then we need to put solder on. We just took all that flux off. And so we're going to put more solder on. That's really the trick here. More solder on. Yeah, that's actually starting to go through now, so that'll be on the other side, which is nice. So we probably just got rid of the crap. Yeah, see how that, I just put a bunch of solder on there, and yet none of it's there. That means that solder finally pumped through, that old solder, and got taken out. So we'll get as much as we can over here. Yeah, that's looking good now. Okay, and now I'm going to flip this over, and I'm expecting to see a bulb underneath. Yep, there it is. Look at that bulb. That's what we want. That means we've gotten rid of that crappy solder. Get that. There we go. So here I'm going to try and finally open this hole up. And again, I'm not going to edit this video, so as many times as it takes. Yeah, this is going to come off now. This is going to be nice. Boom. Hole is open. Perfect. So next we will do this one here. This time I'm going to actually proactively get rid of this silicon first. Again, be careful with these ceramic caps over there. Actually, those are film caps over there. So just kind of get rid of that rubber. And because we're over here, we'll start on this side. Save a flip. It's good to save in action when you can. Okay, so we'll heat that up. That's already going through. Look, I can put as much solder as I want on here. It's just going right through the other side, so that's great. That means we got rid of the old crap. This one, not so much, so we'll see if we can get it to go down there. I have a feeling we're going to struggle with that bottom one a little. Oh, no, there it goes. It just popped through. Excellent. So we're going to take our braid here and get as much surface area as we can on here. We're going to just start sucking. Oh, should we suck all that up? Ooh-wee. We're sucking it all back up. There we go. It's open. That opened on just one side. Use like 4 inches of this braid. Whatever, right? It's only braid. Okay. This one we're going to have to flip over. It's funny. I think that's exactly the opposite of what I thought was going to happen. So we'll flip this back over. Look at how much solder is there. Let's see. Where is it? Here. Nice. That's like 4 millimeters tall. So we'll use the rest of this solder to start that, because, or the rest of this braid rather. That's funny. Okay. There's still solder there, funny. Okay, let's see about here. Okay. We'll start here. Hopefully we can clear this. All right, we didn't quite get through there. I'm going to clean, again, this old flux off, because it's that blackness you see there is pretty used up flux, so we'll clean this off. Don't worry about getting this alcohol on anything. The whole circuit board here is going to be fine. The only thing that you need to be worried about for getting alcohol on is the old butterfly keyboards on the last Apple Intel MacBooks. Those things will die if you put any alcohol on them, but for the most part, everything else on a circuit board will survive that. God, those butterfly keyboards were terrible. Okay, so we're gonna pull on that. See if we can pull this. I think that's through. Kind of hard to tell sometimes. So we're just gonna grab our, well, I lost the one, but I'll grab another through a hole part. Just see if we can stick it through. Yep, so we got through that one. What's next? We've got one over here. Like that. Okay, where is that? There's that. All right. And you can see I've already used this braid up again. So you're going to use, like I said, I'm going to use a whole meter of this braid. And again, solder sucker, I'll say it again. It works great on these through hole parts. I don't really do a whole lot with through holes, so I don't really have any use for solder suckers, but probably be the right application here. Sean can film another video if his method is easier. Okay. Yeah, that fell right through. We're gonna have a nice bulb on the bottom there. That one's not gone through yet though. Okay. Let's see what we can do. All that solder went to the other side, so we're not going to get a whole lot here, but that's fine. Get what we can. Look at that, we already opened that hole up. I bet you we still have some kind of bulb over on the other side. No, not at all. Must have fallen. I bet the solder fell down into our board preheater. Tell you what, man, board preheaters take a lot of shit. And they just handle it, man. Every once in a while you got to clean their gullet out. Okay. So now we're going to take our wick. Like that. Until you stop seeing solder come off, you might as well just keep dragging. There we go, we're through there. Okay, we've got these guys to get. By the way, if you're going to leave your iron for any amount of time after using the braid, you should really re-tin it because the braid takes all of the solder off. I'm not going to do that. I don't really care that much about this tip. It's a big tip. Okay, so I'm just removing the silicon there. And here we have a big piece. I don't know if that's out of the capacitor. No, it's just solder that wicked out, but we might have needed to remove that. Okay, let me get this back over here. Yeah, so we're going to clean these 4 off. We'll do them all at once. Start with this side because why not? If you touch your solder to these film caps, you're going to burn the cover off and then you'll need to replace them, so don't do that. Stay away from those. So we're going to just put solder there. That solder is going through. That's going through to the back. So this solder's coming out pretty easily. And by that I mean that the old solder, we're getting the new solder to fill in the hole on the via that goes through the board. So that's good. Okay. And then we'll take our braid here and we'll just start to pull these off. If for no other reason, after watching this video, you decide that this is just too hard for you, keep the amount of work that this takes in mind as you're deciding whether or not to pay someone else to do this. The prices will probably be reasonable, whatever they are. These do take work to rework. Okay. All right, so we didn't get any of those that time. We'll hop over to the back. Hopefully we can, yeah, look, all 4 of those bulbed up, so that's great. Here, look at those. They're all 1, 2, 3, 4. They all look great. So we're going to use a lot of braid, but we're going to probably get through all those pretty much immediately. Okay. Whoops. That fell off the tip there. The proper tip here, because it has such a nice flat edge at an angle, makes it much easier to track this solder braid. I'm really fighting it here. All right, we're through there. And we probably have enough for this one. Let's see. And notice how I'm pulling this braid up so that it's not touching the parts around it, because this braid gets really, really hot. It's just copper. It's really good at conducting heat. And It'll do that if you let it. It'll stick to all your parts, pull all the solder off of them. All this stuff does is just pull solder off everything. Okay. And you can see here I ran out of solder before I got through. Or rather, I ran out of braid before I got through. So that's not good. We might have to start over there. Once you get all the solder off, it's really hard to get the heat out. So that's why you really want to do it in one attempt if you can. The solder is very good at bringing heat into your vias. Okay. Okay, we didn't get through there this time, that's fine. I'll try next time. Yeah, we got the top one though. All right, so let's flip this board back over again. Both of these have thermal reliefs. They are in that huge ground plane, but fortunately because there are these thermal reliefs there, we will be able to get through this. So we'll pop that back in there. And here's again where your board preheater, or again just your heat gun for your paint or whatever, will really help you out if you have one. I don't know that you could do this without some external heat from a hair dryer, if your wife will let you borrow the hair dryer, or you know, just need a heat source. Okay, there we go. We got that one. We'll heat this one up. I can't tell if I'm through there. I don't think I am, but I'm going to check. I don't know why I keep losing these resistors, but they're basically free and I have a bunch of them. So okay, I'm not quite through there, but I'm going to flip this over. Get that last one. Okay, it's got a big bulb on the bottom. Once you get these big bulbs on the bottom, you're never going to suck it up. Well, not never, but it's harder to suck up all that stuff back through because you're having to suck all that crappy solder back in. So flipping over every once in a while, see what you can do. I think we'll get this. High hopes. Yep, we're through now. I say confidently, but I'm not sure. I lost the resistor again. I have a whole pile of these wherever I'm setting them. Okay, are we through? We're through. All right, so what else do we have? I think we've got 2 more caps. Yeah, we got these 2 over here for sure. So we'll start on the back because we're on the back. That looks horrible on the screen. Let me set this, whatever. To be fair, it's not in focus here either. We're doing these now. Okay, there's already quite a bit of solder here, but I'm just gonna put a little more. This one I found before was the hardest one to do. We got a little ball of solder there. There's just a lot of thermal mass there, and there's no relief on those, so. Nice. Look at this factory short between those pins there. I mean, they're doesn't matter, they're all in parallel, but they're obviously not doing optical inspection in 2000. I mean, to be fair, we were doing it in 2006, but all right. Yep, there's a lot of solder. There we go, we got that one clean. Let's see if we can get this one clean. Good, I think that's through. Let's try this. I definitely should have gotten more braid before I did this, but let's see what we can do. I think we're through there too. All right, so far we've used about 24 inches of braid. This stuff smells horrible, so if you don't have some kind of fume hood or evacuation like I do, you're probably going to get a headache because this stuff, you really shouldn't breathe in. The flux is very strong in this braid. Okay. So get a fan, get some kind of system to evacuate. I hardly even smell it because I actually evacuate outside, but I know that not everyone does that. You kind of have to know you're putting a rework station in as you're building your house to get that one to work out probably. Okay, that through, that's falling through the bottom. Let's see if we'll suck this one more time. Notice that, well, not notice, but this method does not work on delicate pads. If you're doing like an SMT pad, like a 1mm or a 0.7mm, you're gonna rip all the pads off by dragging this braid. So don't drag the braid on smaller pads, but for these through holes, you're never gonna damage those pads that way. I think we've cleaned them all, or rather removed the solder on all of them. I need to make sure that I'm through C301. Whatever this one is, C302. Nope, I'm not through C302 yet, so I thought it was. From this side it looks like I am, but I'm not, I guess. Yep, okay. So this is the hardest pen I've found to clean out, just because again it doesn't have those thermal reliefs like the ones with the ground planes do. So let's put more solder in there. It's a fool's errand to think, oh, there's just a little bit left on the inside of the via. Maybe I can suck it out with the needle. And it's like, nope, just add more solder and try again. You're never going to get as much heat as you need in there. And you know, preheat this with your heater until it's good. You know, get the board hot so that it's preheated. Okay, so I'm done with my desolder. So I need to grab, I used that whole meter of solder I pulled off. Here's a small piece. I just need to tend this before I put this away, because that braid takes the solder off the tip, and then your tip oxidizes, which isn't good. All right, so I'm gonna turn this iron off now. We're gonna just set it out of the way. I need to clean all the crap off of this now. All of this flux you see here, this dark stuff that came off of our braid, it is corrosive. So you need to make sure you clean this off. And we're gonna just use Q-tips and alcohol. I'll zoom out because there's nothing in particular happening there that's exciting. Oh, we don't really need the board preheater right now. So I'm turning that off. You'll still hear it if you're hearing it at all, but it is not heating at this point. Okay. So we're gonna first just do a rough pass to get all the heavy stuff off, and also all the bald solder that's left on here. I'm really surprised that this board doesn't have conformal coating everywhere. It only has it in a couple spots, but you know, it's ultimately a choice that TDK made. It is a mostly sealed enclosure, but it's not a totally unsealed enclosure. It doesn't have any airflow through it. Yeah, I'm surprised in an automotive application that they didn't put a conformal coating over this. If they had, we would have just burned it off. Oh, by the way, these red arrows you see up here are, this was the DCDC that I prototyped the 60S stuff that EEPROM figured out. So this one doesn't have the actual caps, it just has some really bad ones. You know, whatever I had, 0603s, 0805s, whatever those are. I think these are 1206s. So just kind of whatever I had lying around the shop is what went on there. You could replace those at the same time if you wanted to. There's a separate video showing how to do that. In fact, the video that shows you how to get this out of the car also shows you how to put those on, so I'm not going to rehash that here. I should probably fix them, but I'm not going to do that now. This video is already going to be really long, and again, I'm not going to edit it, so you get to see all the paint I do. So those are pretty clean. Still got a little bit of grunge there. You don't need to clean the flux that's here from the factory. That's a washless flux, but you do need to clean the flux we added. And we will wash this one more time before we put it back together after we've soldered these caps on. See how we cleaned those up. Now we'll clean this up. We got a lot of that in here, I guess. So clean that. Nice little solder ball that has now shorted this out. Let's get rid of that. These solder balls will form in reflow when these are first manufactured if the flux all goes away before reflow occurs. So if you heat the board too slowly, then you get bald solder. Like that. Okay. If you use like an ultrasonic cleaner, that will get bald solder off in a flash. But I don't recommend using ultrasonic cleaners on boards once they're assembled because it will ruin your connectors, it will ruin a lot of capacitors that aren't made for SMT and rewash. So unlike this alcohol, which we can just put wherever we want, if you're using an ultrasonic cleaner to wash this, well, one, I wouldn't, but two, you need to take all the parts off that aren't washable. The data sheets will typically say whether or not a board is washable. Okay. So yeah, you need to make sure that you're getting all that flux off that's sticking on these pads, because good flux oxidizes everything. That's really what it's supposed to do. It's supposed to kind of be a sacrificial material so that the stuff you're trying to solder isn't going to oxidize, and it'll also wash. It'll have a chemical reaction as you heat it up that will wash and wet that surface for you. No need to post in the comments that that's not a completely technically correct explanation. That's close enough. Okay, so we'll start cleaning this side here, and I'm trying to decide if that capacitor leaked. We do want to look and see if these old capacitors leaked. I'll need to find them, all the ones that fell into our board preheater there. I also recommend, so this whole area needs to be cleaned because when we put this new silicon on, we don't want there to be any residual here that the silicon can't stick to. So get that old silicon off. I'm using a plastic scraper here to help me with that. Okay. Yeah, you use a lot of Q-tips on this. And I'm just putting, again, just 99% isopropyl. So that guy's good and clean. I don't think there was any leakage on this one. I don't see any attack on the PCB. All right, so this still has a little bit of solder there. We can probably get away with not cleaning that out. Missed that before. There are more aggressive solvents that you can use to clean, that like spray-on aerosolized solvents. I don't use them because they're typically not great for the environment. I struggle through with rubbing alcohol. I think we'll be able to put a pin through that. You can see how there's still a little bit of solder there. I think that's going to be fine though. Okay, I am going to scrape this old silicone off here and there. Okay, yeah, like that. Also here. Nice. Okay. So if you do have flux on these pads, you need to make special attention to get that flux off because, not flux, sorry. If you have leaky electrolyte from your capacitors on these pads, like here, see how this is really dark. This is one that we saw earlier had definitely leaked. I'll zoom way in on that. I think I'll be able to focus on it. Yeah, look at how gross that looks. So this pin here, I'm gonna have to play with the exposure. Certainly had a leaky cap. This program freezes a lot, and it has just done that. Sorry, so I'm gonna have to force it to quit, and then relaunch it here. Okay, connect. Yeah, okay, we're good. I think the dock coming up made it freeze. So all of this green junk you're seeing here, it needs to come off because the solder is not going to stick to that. The flux can't really attack it, and so the solder is not going to stick to it. Now on this trace here, because this has been attacked so much, I'm going to be coming from the top left and dragging to the bottom right because that's where the copper is. If I go the other way, it's possible I could rip this pad up because it's been attacked so much. But I probably need to zoom out a little so you can see what's going on here. There we go. How's that look? That looks better. So yeah, I'm going to basically come in here, and you can see that that's been attacked quite a bit. If you don't clean this off, you're going to have a really hard time getting the solder to form properly to make a nice clean solder joint there. So anywhere where the electrolyte has leaked out, make special care to clean it up. You can see how gunky that is. I think I'm going to take and I'm going to reheat. I'm going to turn this iron back on so that I can clean that off a little bit by putting some more solder on it. I might have to clean it out a little more. Goodness, that's a disaster here. We'll clean it up though. All right. It's just very messy. Also, the electrolyte readily attacks the silkscreen, this white silkscreen. So if your silkscreen starts to come off, this white stuff, which it hasn't here, don't worry about it. That's just for you, the user, to see. All the white on here is just basically paint, so that you can see that this is, for example, C203 or whatever. All right, I need to turn this auto exposure back on without making the dock show up. And nothing changed. Oh, oops, I guess it was on. Sorry. Seems kind of dim. Whatever. Wish you could tell it to increase the exposure in the auto exposure. Okay, let's zoom out of here. Our iron is probably nice and warm. This terminal has also been attacked slightly. You can see with that really rough surface here. So certainly that one. We're going to basically I'm going to start with this solder braid and see if we can get rid of this crap on that surface there. The risk you run here is that you might fill this hole back up. I'm just going to heat this up with the iron. No solder, just kind of push that crap off so that we can clean it off. Maybe get a little more of this braid in there to get that flux. Again, the flux doesn't attack this very well. It'll do the best it can. I'm going to do the same thing over on this one because it looks a little rough. Let's see what we can do. Yeah, that cleaned up pretty good. So that one's good. But you can see this one's still a bit messy. I think I'm going to actually put a little more solder on this. Hopefully this clean solder can displace some of this so we filled the hole back in now. So now we don't have to worry about filling the hole in because it's filled in. Okay. Yeah, so that's good. We've done that. Now let's get this to come back off. So the two problems with leaving this electrolyte on here, one, it's going to keep attacking these copper surfaces. Yeah, so we clean that off now. It's going to keep attacking these copper surfaces, and two, it's going to make resoldering this very difficult, but we have cleaned that up well now. Of course, now I just need to pop that hole through again. And it's there, not in focus at all. Yeah, so a lot of that stuff just fell through the bottom. I'm going to try and tell you what, did you give up? Oh, I can. Is this the target? Look at that. I've never figured that out. Okay. My complaint about lacking feature is unwarranted. Feature exists. Okay, yeah, there's some crap on that. Let's see if we can clean this up. Is that not focused for you? Yeah, there we go. Okay. Yeah, that cleaned out good, but I think we have a bulb half open on the other side. That's exactly what we have. Okay, it's that one. So, we've now done that. That's fine, we'll come and suck that off here. Look at that. That looks a lot better than it did before. So, compare that to before. That looks a lot better. Of course, it's got all this flux we need to get off there, but that's fine. Zoom out somewhere usable. Okay. Look at that, it looks great. Okay, over here is looking good. And I think we've just got these two left in there. Maybe we already did those, I don't know. We didn't do that though. Nice. Okay, probably should retin that tip. Yeah, I'm gonna turn this off and retin it. If I weren't making a video, I'd probably just do this quickly, but I don't want to cut corners. Okay, we're an hour and 7 minutes. How to replace 9 capacitors in an hour and 7 minutes. Okay, so I'm kind of just taking a more overall view and just looking where it's still dirty here now. Pop this off. And you can see there's some dirt here, and just kind of clean this up. Probably don't need to, none of this is really that conductive, but anywhere where you have that flux definitely needs to be cleaned. Oh, I wanted to show you the other PCB that had a lot of damage from it, just so you can see if it's really, really bad. This PCB is the best one I've looked at. I mean, it still had leaking capacitors. This one was not. This one had all kinds of leakage. Look at this C303 here. So if you notice here, the electrolyte, this is actually Sharpie, I believe. Yeah, I Sharpied this from the old, whatever. That's not leaking electrolyte, that's a green Sharpie. But you can see how the leaking electrolyte attacked the silk screen here. It also attacked the surface. This is cleaned. I've already cleaned and reworked this as best I could. But the electrolyte out of these capacitors is very corrosive, and it eats copper for breakfast. That one leaked pretty bad. Up here, this just got totally messed up, and so I actually had to cut some of the copper trace off the top here and then run solder on top of it just to make it better. So I did have to do a little rework here on this. Does that look as bad as it looks here? No, okay. But anyway, you can see here too, this is the one where that plasma came through. This one actually had a failure, and that plasma came through and burned that out. And here I haven't removed the thermal paste, and so now I have it all over my hand on this blood and thermal paste rag. C551 leaked on this one as well. There. And you can see where it attacked this surface here to the ground plane. You can see that there's some residual attack there. I don't think those leaked, but this one leaked too. I didn't find this one's leakage until after I took the capacitor off. But I just wanted to show you what worse capacitance looks like. Oh, and by the way, as you're dragging this, I'm doing it on like a wood surface that's pretty malleable or whatever. It's just a piece of plywood. The parts on the back here can be damaged if you are, on a regular surface or you're just like jamming this into stuff. These pins are doing a lot of protection here on the through holes, but you don't want to like break these chips. So I'm always, when I'm sliding these around, I'm doing it very gingerly. It's not just like go this way, go that way. All right, so let's go back to our other guy here. And in fact, we'll use this guy as a template because it has all the correct colors on it. And we're gonna basically put our new capacitors in. They come in a bag. I don't know if this is the bag, but we'll see. We are gonna dump these all out, ideally into a bucket. Take this recap 2025 or 2026 or whatever, and we're going to take this and just put it right next to the serial number on your DCDC body here, just so you know it's been reworked. That way, if someone coming down the road wants to know if something's been reworked. In fact, let's put it up top here like that, because then you'll be able to see it from the top of the car. So I'm gonna take some rubbing alcohol, and I've just knocked it all over my counter. Whoops. And I'm gonna just clean this. Let's put it like there. I'm gonna just clean this surface like that. And then while that's drying, I'm gonna make sure the lid's not gonna cover it. All of my lids have screws in them. Okay, this lid, move out of the way. Lid goes like that. Let's put our recap. I mean, we could put it on the body there. I'm gonna put it right there. Seems like a good spot. So that way down the road, someone wants to know if it's been recapped. Yep, it's been recapped. Save someone the time of having to take this apart. And once again, I have thermal paste all over me. That's why you remove the thermal paste, because it's annoying. Okay. So, where were we? We were putting new caps in. So, to do new caps, on the electrolytic capacitors, which are the round ones here, there's, I guess 6 of them. We need to make sure that the polarity is correct. If you do the polarity wrong, electrolytics basically will blow up. So, it's not dangerous, but it will not work if you do them wrong. So, we're gonna just kind of mix and match, or pick a capacitor, see where it goes. These 330 microfarads, they say on the side, 330, 25 volts or whatever. We're gonna put those in. The negative side goes towards these transformers, like that. So I've got the negative here on the text there, and we're gonna just pop that. Well, I'm gonna maybe break this silicone off here, like that. I'm gonna put these through like that. And I'm gonna show this to you once, and then I'm gonna just do it after that, so I don't have to keep flipping this over. Once I stick this through, I'm gonna take the pins and I'm pushing up on the capacitor so that the capacitor is as close to the circuit board as I can get it. And then I'm gonna just pull the pins like that. And then I can let go and that capacitor is just there. So we'll do the next capacitor, which is the same. It's another 330 microfarad. The negative goes towards the transformer. Pop that through. Is this the one that had the, there we go. So once again, I'm gonna put my finger here. I said I wasn't gonna show it every time, but I'm gonna take this and pull that direction, pull this that direction like that. And then next up, we have this guy here. This is a 68 microfarad cap. And again, the negative is gonna go up like that. So here's our negative terminal there. And this is gonna go up like that. Now in this one, you don't need to cram this one in because this one doesn't actually touch the circuit board, but just push it to where it's not, you know, falling back out. And again, I've folded the terminals there. Okay, so now we've got these two here. These are 47 mics. In fact, all three of the remaining electrolytics are 47 mics. So it looks like all of our negatives point up. So if you look here at the board, negatives pointing up, negatives pointing up, negatives up, negatives up, negatives up, and negatives up. So negative is always up on our electrolytics. So that's convenient. So we'll just populate these three. So here's 1 and 2. And then 3, and I'm going to put a finger on each one of these, or maybe, probably should have stuffed all 3 of those at once. Okay, so here's 1, like that, and you want to make sure that break is happening as close to the circuit board as you can so that the part can't back out. So like you want the angle to be right there where the via comes through. Okay. Don't fold them all the way over because you don't want any solder that comes through to like touch the other parts and then stick to the part. Okay, so now we're doing our ceramic capacitors. Now these were electrolytic, but I replaced them with ceramics because the circuit really warranted it. You have 2 bigger ones and 1 small one. The 2 bigger ones are going to go in C303 and C551. So we'll put these through like that. These are not polarized, so you can put them through either way you want. There is no negative terminal is what I'm saying there, or positive terminal. It's just whichever way you want. That is just comes down to properties of ceramics versus electrolytic capacitors. Okay. So there's that. And then we've got this 2.2 microfarad that goes down here, like so. And we'll flip this up. Like that. All right, so we've got all of these populated now. I'm going to finally remove that carrier, and I'm going to take this. At this point, I'm going to turn my board preheater on. I probably don't need it, but heat is always helpful in soldering. So the more heat you can get in, the better. Where am I going to set this? Like that. Perfect. And we're going to just go in and just solder these all on. So I'm going to get a piece of solder here. That's not going to be enough. We're waiting on the iron to heat up. No, I haven't even turned it on yet. But now I have. There we go. More solder. Just like the wick, I always just cut my solder off. I don't like to be bound by the roll. I don't like automated solder feeders. I don't like solder pens. I like to just handle solder. Always your personal preference, however you want to do it. So we are going to get here. Move this seat down a bit. Move that up. Now I need to move this seat up a bit. That's why. Okay. So we'll start here. Just kind of picked random ones. Doesn't really matter where you start. We'll get those guys soldered. And this is the easy part. You've done all the hard stuff at this point. We are now going to just solder these. So the first thing I'm going to do is get my vent hood into place so I don't have to breathe all these fumes. And then I'm going to take and clean my tip off, solder it, clean that off again, and here we're going to solder this. So I can't even see the end of the tip. Look at that. Boom. That's soldered. This is why rework takes so long. Cleaning the old solder out. Solder is designed to just wick and spread everywhere, but look how fast this is. We just spent probably an hour and a half. Yeah, hour and 18 minutes getting these 9 parts off. If I weren't so rambly, we'd get these new parts on in a minute or two. But even then, it'll probably only be a couple minutes. So here's this one. Okay. The solder that I recommend, the MG Eutectic, has a no wash flux, so you don't need to actually wash the flux off when you're done. I still will generally wash it off when I rework, just because I like things to look clean, but you probably don't need to but we are going to do it in this video. Okay, that was that via that was annoying to clean out. Okay. All right. This was the hardest one to remove, but look how cleanly this is going to go in. It's still a little difficult. Okay. Tell you what, that board preheater is burning my hand. Okay, did we get them all? I don't like the way that one looks. I need more solder. I almost did it with just that much solder. Yeah, now I'm happier with that. Okay. This is fine, but I just don't like the way it looks, so I'm going to just clean it a bit there. All right, so we have now finished, I think, soldering these. Nope, we forgot one. So do make sure you solder them all. It'd be bad if you didn't. That's got a piece of silicone junk in it. This right here, clean that out. Okay. Boom. Okay. All right, so now we've soldered. Now we need to cut these terminals off. I'm using some flush cutters. I don't recommend Klein tools anymore. I still have a few pairs, so I'm using them, but they're not the best. They tend to wear out quickly, and their lever mechanism it wears out. So I don't recommend these. Get other ones. Okay. I'm just cutting all the terminals off. Maybe I'll zoom out a little so it's easier to see that. These through-hole pads, you are not going to rip them up. So if you need to flex the terminal a little bit, through-hole parts are very hard to... I should probably turn this heat off. I don't need that anymore. Okay. That's why I really like through-hole connectors. It's really hard to rip them off. Whereas surface mounts, you've only got that copper and the glue holding the copper on. With through holes, you've got the hole and all of the plating. Okay. Make sure as you're cutting these, you'll notice I'm grabbing each one because you don't want these flying all over your circuit board. They're obviously metal and they conduct. So I'm retaining each one and just manually throwing it off. If you lose one, make sure you find it before you put this back together because you don't want to short out your high voltage DC-DC converter on the inside. Okay. So I believe we have now cut all the wires. We can flip this over, make sure everything looks right. Yeah, these are good. Those are all flush, looking good here. Try not to move these these ceramics too much because you don't want to break the connection on the inside. And the electrolytics as well. You know, just leave everything where it is. You've already soldered it in place. This guy's not perfectly straight, but that's fine. It's not going to hurt anything. There's no reason to straighten that out. We'll just glue it. Okay, so now I'm going to clean the back side of this board off with more alcohol. And if you remember from earlier, I dumped it all on the cabinet, so I'm going to put some more. And just do a little quick cleanup here on the 9 parts we reworked. So that looks fine. There's some junk there. Okay. Here's some here. I mean, yeah, this is pretty clean, so we're not having to do much work, but. Okay, and then we had 2 over here. Go away. See, I've still got a little bit of flux there. And over here, there. Yeah. This no wash flux, I mean, you can see it's not nearly as caustic, so it's not gonna mess things up as much. We've got 2 more over here. Yeah. This is not the perfect joint, but it's fine. It's good enough. I'm not going to rework it. It's definitely making contact. Typically a ball up like that, you would want to make sure that you have hit the whole pad. In this case, I'm confident that's fine. Okay. You'll never have issues with that. If there's any doubt, put more solder on it. Okay, so that is the soldering rework, and for some reason I've left my iron on this entire time, and I've also just smashed that camera. And so we're done with that. Let's get that out of the way, turn our iron off, give it some sympathy solder here before it cools down too much. Sorry, buddy. Okay, and then we'll just put that over there. Okay, the final thing we need to do is we need to put some more silicone on here. I'm using Chip Quick EGS10C. This is a 20-gram size. When you take this lid off, you're going to need to cut the tip off. You can cut it straight or an angle, whatever you want. And we're basically going to glue these parts down at this point. This tube is more than enough for one application, so just I think I want that to be a little bigger. I'm going to cut a small angle on it. And yeah, we're going to just apply this glue. It's non-conductive. You can pretty much get it on anything you want. It's not going to affect anything. So I'm just going to cram it down there. Now obviously if you're reworking a bunch of these, you might want to conserve this, but this tube, once you cut that tip on it, is only going to last, you know, 3 or 4 months anyway. So if you're just doing a one-off repair, go to town. Silicone everywhere. On this one that's sticking up, I'm just going to stick it all the way underneath it. Sean had theorized attaching it here to this transformer, so I'm going to do that. I figured the scope might actually be useful. I moved it out of the way because... So you can see I've just put this everywhere here. Yeah. Is that in focus? That's better. All right. So we're going to put it around this cap here. The goal here, you know, all these capacitors are 2 terminals. The goal here is that the capacitor can't sit there and rattle its terminals off. This does not need to look pretty. Even these ceramics, I'm going to put some on. Come over here, just so it doesn't fatigue. No one is winning awards here. I am not an artist, so this is serving its utilitarian function well, and I'm applying probably way more than I need. But that's okay. Okay, let's glue these on. Do note, you don't want to put this glue on before you solder, because if this silicon gets in the hole that you're going to put solder in, the silicon is going to win. The silicon is not going to melt or get out of the way, and then you're going to have a really bad solder joint. So sometimes people will think that you should apply glue to the bottom of the capacitor and then stick it in. That's a recipe for bad solder joints. So do apply the glue afterwards. Okay, so we have now glued that very sufficiently, and all we need to do is just put this back together. So now, get the iron off. We will put this back together, and to do that, we're going to take this, and we need to clean the man, it's late, sorry. We need to clean the thermal paste off of here. I'm just using alcohol again. If you get the alcohol on this sticker or that sticker, those stickers will come off. You know, it doesn't matter if the stickers come off. It's not like you're going to void a warranty on a 25-year-old car, but I like to keep the stickers when they're there. There's our first pass. Here's our second pass. Okay. And then we'll take and dry it like that. Okay. And even though we already cleaned this other one, I'm going to recommend that you clean it again because we've been touching it and handling it. So I'm going to take And clean this again, like that. Wait for that to flash off. And while that's doing that, we're going to take our thermal paste. You can use any thermal paste you want. I just happen to be using this Thermal Grizzly Hydronaut. This is complete overkill for this application. This is a very low thermal resistance paste. Any paste is going to be fine. All right, so I'm going to just take this paste, make sure that alcohol is dried because the alcohol is going to break this down. I'm going to put that paste here. I'm going to put it there. You don't really need to put it near the holes. And I'm going to put some there. And I'll put a little right there. That's about how much you want right there. If it does squeeze out, it's not going to squeeze out onto anything that's important, so don't need to worry about that. You can take a little spreader here if you want. This is the spreader we were using to remove all that junk, so I'm going to make sure and clean that blade off because you don't want crap in this thermal paste here. And we're going to just use the back edge of this and just kind of like pre-flatten this. Doesn't need to be perfect. This is not a, 200 amp CPU that's going to be sinking 500 watts. I think this thing, the worst case, is like 100 watts or something that it's dumping, a couple hundred watts that it's dumping into here. Don't quote me on that because it's late. But it's not that much. I think it's actually less than 100 watts now that I think about it. All right, so something like that. Again, doesn't matter where you get this stuff, as long as you're not using a conductive thermal paste, which I definitely don't recommend. You would probably know if you had a conductive thermal paste because they tend to be quite expensive and very application specific. Okay, boom, there's that. Set this aside somewhere that you don't mind it getting messy. You'll want to make sure you clean that. Okay, so now I'm going to take this and pop these connectors back on. They are keyed, so you can't do them wrong. And we're going to take this guy, and I use these 4 holes to line it up, and then just put all of our screws back in, and that'll be it. I didn't show you taking the screws out, but I might as well show you putting them back in, because at this point you can stop watching at any point because the installation is done. All right, so I'm going to put these screws in first, and I'm going to just drop all 3 of them in. Okay, 2 and 3. None of them are tightened, so we're going to just get them all to insert first. So go all the way there until you feel resistance. Okay, there's that. Okay, there's that. And then now we're going to put all the other screws in, so all of those screws are still loose so that we can line all of these up. Okay, the bigger screws go into this is the HVDC input. That one is too tight, so I need to back that off. Here is our 12 volts output that's going into a flyback coil. And we've got a few more screws. So see how this screw does not line up? Because we've left all the screws loose, we can actually go in there and line that up properly. Okay. And 3. Okay, so now we've got all the screws in. The first thing we need to tighten is this block, and the first screw we're going to tighten is the middle of the block. So we're going to tighten that down, just kind of finger tight. That's going to help our paste spread to where it's not all flowing to one side. It's going to make it flow out both directions first. And then we're going to do this one, tighten that up. Do that one, tighten that up. And then we'll go ahead and tighten these all the way. I do not know a torque spec, but you can see on my hand it's not that much. It should be tight, but it doesn't need to be Gorilla tight. You'll feel it's very obvious when you get the end of travel there. Okay, next I'm going to tighten these 4 here. So 1, 2, 3, 4. Then finally I'm going to do all of the metal brackets here that are very flexible. So 1, 2, 3, 4, and 5. Okay, and so that is the DC-DC repair. The final thing I'll say is that when you're reassembling this, these are for a different DC-DC converter, you'll want to make sure that you have all of these plastic grommets. Here, they kind of move around. And when you put this cover on, I go over it in the other assembly video, but you need to make sure that it's in the right spot. And again, you should go back to that other assembly video at this point and watch it where it shows you where that right spot is. Because to be honest, I don't remember right now which one it goes in. What am I hitting? Okay. Yeah, that was right. Okay. So make sure these plastic grommets go in there and those go there, and that you should still be able to see this second ring here. You don't want the metal to be in that. It's in that closer ring. Okay, so that is the reworked DC-DC. You could put the 4 screws that are in there. You can see our 2025 recap. It might make sense to put that label here instead. This is visible from in the car. We'll figure it out. So that's the rework. Hour and 35 minutes. Honestly, not too bad. Under 100 minutes. Thanks for watching.